Part 4, this next piece, is to be able to recognize the organic compounds, the hydrocarbons, and be able to name them. So again, to recall, organic compounds are any covalently bonded compound that contains carbon. Exceptions are carbonates and oxides, where you see oxygens bound to carbons and also cyanide. So again, hydrocarbons are the simplest organic compounds, and they only contain hydrogen and carbon. They can make many different shapes, sizes, lengths, and again, carbon must form 4 bonds. So here we go. This is what we're going to be doing now. This is the key point, naming hydrocarbons. Alkanes is a type of hydrocarbon. And again, these are the ones that have single bonds between the carbons and the hydrogens. Alkenes have 2 or more carbons and where there's a double bond between the carbon, the 2 carbon atoms. An alkyne contains 2 or more carbons, and this is where you see a triple bond between 2 carbons. There's actually a pattern here, and you need to know this formula. Alkenes, the number of carbons is stated here, and hydrogens is twice the number of carbons added to 2. So for example, if you take this example here, ethane has 2 carbons and 6 hydrogens based on this formula here. You just plug it in. 2 times 2 is 4, plus another 2 is 6. Alkenes, again, remember that there's a double bond in between 2 of the carbons, and it has this formula. The number of carbons and the number of hydrogens, there's twice as many. So for example, ethylene has 2 carbons and 4 hydrogens because of this formula here. Lastly, alkynes. Again, this is where you see a triple bond between 2 carbons. And again, it follows this pattern here. You have 2 carbons, and you figure out the number of hydrogens based on this formula. So 2 plus times another 2, which is 4, minus 2, which is 2. Now, naming has to do with the number of carbons. So if the compound has only 1 carbon, then the prefix is meth. 2 carbons, the prefix is eth. 3 carbons, prop, so on and so forth. 4 is but, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. Now, you might have heard some of these prefixes before, such as methane, or propane, or butane, or octane. Again, those prefixes refer to the number of carbons within the hydrocarbon compound. So taking a look here, whenever you're dealing with an alkane, you have to be able to recognize it based on the pattern of carbons to hydrogens. When you recognize an alkane, you add the suffix ane at the end next to each prefix. For example, if you have 1 carbon in your alkane, you are a meth, and then you add the suffix ane. 2 carbons would be eth, and then ane at the end. Alkenes, same thing. You use the prefix to denote the number of carbons, and then you add the ending ene next to each prefix. For example, if you have a 2 carbon ethene, and again, you have to recognize it based on the pattern. F is the prefix, Ene tells us it's an alkene, therefore we know it has a double bond. So that's how you name that. Last one, alkynes. Again, you add yen or ine next to each prefix, and a 2-carbon alkyne would be named ethyne. Taking a look here, here's some organic alkanes. Again, this refers to the number of carbons. Next to each carbon, you'll notice a number or a missing number, and you know that refers to 1. And again, you have to pay attention to the number of hydrogens to figure out, does this fit the pattern? Hydrogens in alkenes refer to 2x plus 2. Okay, and all of these should fit that pattern. Alkenes, again, fit the pattern of hydrogens equal 2 times the number of carbons, and again, these all should fit the pattern. And again, here are your prefixes. Now, why is this one missing? Well, remember that alkenes have a double bond, and there are no examples of a carbon double bound to itself. So that's why that one's missing. Organic alkynes, again, follow the same pattern of hydrogens equal 2 times the number of carbons minus 2. And they should all fit that pattern there. Okay, refers to the ending, and then you have all the prefixes here that tell you the number of carbons. Here's some examples of some simple alkanes. Notice meth refers to the 1 carbon, F refers to the 2 carbon, prop refers to the 3 carbons, but refers to the 4 carbon skeleton. Okay, and then the anes at the ending refer to all the carbons bound only once.